So today we're going to do section 3.5 from the Honors Pre-Calc book, and I think the best way to do this is to use the handout that I gave to the substitute. Try to solve these equations on your own, and then you listen to the video. You might pause it as you go, like try to solve number 1, and then pause the video and see how I solved, start the video, see how I solved it, and go from there. So for number 1, we're trying to solve 3 to the t minus 4 power equals 48. If we change this into logarithmic form, we have a log base 3, a power of 48, and the exponent is t minus 4. So I'm going to do a change of base, and we've always said for the change of base do log of 48 divided by log of 3, but you don't have to do it that way. You can go to math and scroll down until you see log, which I think is 0, but we'll scroll down until we see it. There it is. So it's A. So hit log base, and we have a base of 3 and a power of 48, which gives us 3.524. So we get 3.524 equals t minus 4. So when we add 4 to both sides, we get 7.524 equals t. Now it says, and then find your answers using a graphing calculator. The way we're going to use the graphing calculator to do this is we're going to say y sub 1 equals 3 to the t minus 4, and we're going to say y sub 2 equals 48. And then we're going to look at where these two graphs intersect, and it's going to confirm that our answer is correct. So let's go into our calculators and clear out whatever's in y sub 1. And in y sub 1, we're going to put 3 to the t minus 4 power. So hit 3 to the, now be sure you use parentheses. Obviously, we're going to use x minus 4. And then in y sub 2, we're just going to put 48. Now we need to make sure our window is going to accommodate this. So let's make our y maximum go up to 50. And let's make our y scale 5 just to make our graph a little bit prettier. So when we graph these now, we see our first curve, our second curve, and we want to find the intersection of these two curves. So I'm going to hit second, calculate, and I want to find the intersection, so I'm going to hit 5. It asks for the first curve, and it already has the line on the blue curve, so I'll hit enter. Then it asks for the second curve, and it has the line on the red curve, so I'll hit enter again. And then it says guess. Well, I don't want to, so I'll just hit enter again. And it tells us that it's 7.524 is the x value, and the y value is 48. And that confirms our answer. So in all of these, you can put them in your calculator that way. So this next one, we're going to divide by 140 on both sides. So we get 1/2 t over 4 equals 350 over 140. So the zeros will cancel out. So I'm now going to change this into logarithmic form. So I have a log with a base of 1/2, and the power is 35/14, and that equals our exponent, which is t over 4. So I'll go into the calculator, and I'm going to quit out of here. Oops. Go to math, and I know I want a, so I should be able to just hit alpha a, and that gives that to me. And so my log has a base of 1/2 and a power of 35/14. So 0.5 and 35 divided by 14. So we get negative 1.322 equals t over 4. Multiply it times 4. Oops, nope. We get negative 5.29. And again, you could just put that in your calculator. You could put y sub 1 equals 140 times 0.5. When you raise it to the exponent, be sure you put the t divided by 4. And then on y sub 2, put 350. And be sure that you change your y maximum to go up to like 400 and do a scale of 50 on the y values. Okay, so this next one, we want to get our numbers that have an exponent of x on one side. So I'm going to divide by 2 to the x on both sides. So I get 4 equals 5 to the x, over 2 to the x. Now I can change that to 4 equals 5 halves to the x power. When I put that in logarithmic form, I have a log with a base of 2.5, a power of 4, and that equals x. So I'm going to put log, I'll go to math and hit alpha A. We have a log with a base of 2.5 and a power of 4. We get 1.513. And then over here, this one is a little bit more challenging. And as always, I'm going to say it's like you're doing little puzzles. So sometimes it's just a matter of trying something. So if we play around with this one, let's say that we want to use this side to determine what our base and exponent is, which would make this side our power. Now we could have done it the other way around, but if we do it this way, we're going to have a log of base 3. Our power is 7 to the x minus 1, and that's going to equal our exponent. Now if you think about putting this in expanded form, this exponent is going to move out to the front. So we're going to say x minus 1 times log base 3 to the power of 7 equals x plus 2. So let's go to our calculator and change log base 3 of 7 log base 3 of 7, 1.77. So we get that x minus 1 times 1.77 equals x plus 2. So 1.77x minus 1.77 equals x plus 2. So subtract 1.7x from both sides and we get 0.23x. Subtract 2 from both sides and we get minus 3.77. So we're going to divide negative 3.77 by 0.23. I'm just looking at my work to make sure I've done that right. Oh wait, no. If I subtract 1.77x from both sides, I have made an error. I'm going to get x minus, I get negative 0.23. I stand corrected again. It's going to give us negative 0.77x. So we're going to divide negative 3.77 by negative 0.77. We get 4.896. So number 5, again, think out of the box, think creatively. We're going to pull out a 2q. And that's going to leave us with 2 squared minus 1 equals 48. And you can always check it and make sure that that distribution will indeed give us that exact same amount that we started with. But 2 squared minus 1 is just 3. So we get 2q times 3 equals 48. Divide by 3 on both sides and we get 2 to the q power equals 16. Well, 2 to the q power equals 2 to the 4th power, because that's what 16 is. Therefore, q would be 4. Okay, the next one. Let's change this. We need to change this so that we have log base 10s on both sides. So right now, this one is a log base 10. So we're going to have log base 10 u minus 7 to the 3rd power. Now, if I want 6 to equal a log of base 10, what would that power have to be? Well, it'd have to be 10 to the 6th power. So that would look like that. So now we would say that u minus 7 cubed equals 10 to the 6th. So we're just setting the powers equal to each other. Now if I cube root both sides, I get u minus 7 equals, the cube root of 10 to the 6th is going to be 10 squared. So that's going to be 100. Therefore u is going to equal 107. Now going over here, that we're going to do a similar thing on number 7. We need to find a base 10 that would equal 2. So we can condense this on this side. It's going to be log of z times z minus 15. And over here, if I want a log base 10 that equals 2, that's going to be a log of 100, because 10 to the 2nd power would equal 100. So we now want to set z squared minus 15z. Oops. Let me write that again. Z squared minus 15z is equal to 100, because that's the power over here equals the power over here. So z squared minus 15z, I don't know why that keeps happening, minus 100 equals 0. So we need to factor that, and 20 and 5 will work, so we want z minus 20 times z plus 5 equals 0. So z will be 20 or negative 5, but you can't have a negative power, so that's an extraneous solution. So in this case, z equals 20. All right, natural log of t equals 2t minus 3 minus the natural log of 1 over t. Let's get the natural logs on one side. So we're going to get the natural log of t plus the natural log of 1 over t equals 2t minus 3. So let's condense this. So we get the natural log of t times 1 over t equals 2t minus 3. So this is the natural log of 1 equals 2t minus 3. Well, anytime your power is 1, that equals 0. So when we solve this, we get 3 equals 2t, and 3 halves equals t. Okay, number 9, we get that the log 2x squared plus x equals the log of x plus 2 squared. So we're going to set our powers equal to each other. So we're going to say 2x squared plus x equals, now if I square that out, we're going to get x squared plus 4x plus 4. Subtract x squared from both sides, and we get x squared. Subtract 4x, I said subtract x squared from both sides, we get x squared. Subtract 4x from both sides, we get minus 3x. And subtract 4 from both sides, minus 4 equals 0. So that's going to factor to x minus 4 times x plus 1. So x equals 4 or negative 1, that's extraneous. So x would have to equal 4. So this one is similar to the one that we did a few problems ago, where you just kind of have to start doing something. So we're going to say that 18 is our base, and this here is our power, and w is going to be our exponent. So we're going to do a log base 18. The power is 4 to the 2w plus 1, and that equals w. So that, if we expand that, that becomes 2w plus 1, in parentheses, times log of 18 power of 4 equals w. Well, log of base 18 to the power of 4 0.480. So when we multiply that out, we get 0.960 plus w plus 0.480 equals w. So 1 minus 0.960 0.04 equals 0.480, and 0.480 divided by 0.04 is 12. And there's probably other ways that you could have gone about solving that. So this next one, I am going to say w to the 4th log 5w. And I'm just going to add that other term to the other side. So that's going to equal 17w squared log 5w. Now, because these two parts are exactly the same, I know that these two parts must be equal to each other. So I'm just going to say w to the 4th equals 17w squared. Now, we can't just divide by w squared on both sides, because what if it were 0? So we're going to say w to the 4th minus 17 w squared equals 0. Pull out w squared. So this is going to give you w squared times w minus square root of 17 times w plus square root of 17. So your solutions would be 0, negative square root of 17, and square root of 17. Well, you can't have 0 for a power, so that's extraneous. You can't have a negative for a power, so that's extraneous, so w would equal square root of 17. Okay, last problem is essentially the same thing. So I'm going to say that z cubed e to the 5x equals 3z e to the 5x. So, because these parts are exactly the same, then z cubed must equal 3z. So z cubed minus 3z equals 0. So z times z squared minus 3 equals 0. So z is going to be 0 or plus or minus square root of 3. 0 won't work, negative square root of 3 won't work, so z is only the square root of 3. And that's it.